Welcome back to Databytez, your source for data-driven content. Today we are focusing on the technical side of data, looking at data structures once again, this time in two relevant technologies, one being Python and the other one being Excel. So you might not be a programmer or even aspire to be a programmer, but the point here is that by leveraging the kind of knowledge that programmers use, software engineers are known, you can make life a lot easier. And if you wanted to transition to eventually become a programmer, you'll see that a lot of this stuff repeats. And so it's useful in the sense that it can help you solve your problems easier, and the fact that it allows you to then start leveraging it in one way and then understanding it conceptually, and so when you increase in complexity, you're able to readily apply it. And so we're starting off our discussion with arrays and lists, one of the big three, the first of the big three. And here I have three different modules that I'm importing. I don't really want to spend too much time. I'm going to try not to get into the nitty gritty here about what's going on. This is a integrated development environment, also known as an IDE. And this is kind of where if you're a programmer, you're spending all your time here. And I'm able to leverage arrays and lists in a multitude of ways. And this is just to kind of show how this keeps recurring, how arrays show up time and time and again as a concept. The data structure just rears its head in different formats, and it all works the same way. They just call different things, and they do operate a little bit differently. But essentially, you can do the same things. So the first one we are constructing with the array module, which I imported. And this type code just tells me what kind of information I'm putting in here. And let me actually get rid of this. This will come important to later, but I'm able to create this. If I run the code. And so I've created my array of 5. If I were to print this, I'm able to see 1, 2, 3, 4, 5. And again, this is just saying I have the same type. It's called of a class array, and I'm able to iterate through, meaning I can print out each value, return it out one at a time, each element within the array. And again, I'm able to do this thing with also the NumPy array, which is its own thing. I can run all of this. And it says, here's my array here, 1, 2, 3, 4, 5. Again, 1, 2, 3, 4, 5. It looks a little different because it's a slightly different spin on it. And it's a different class, but I'm also able to print out each element. I'm able to operate element-wise and do 1, 2, 3, 4, 5. Next is the Panda series. Just another spin on the same thing. Pandas is something that is a tool for data analysis in Python. Same with NumPy, built on each other. But I have a little bit more information saying, what kind of data type is it? Data type's its own thing that we'll cover. The class, and again, just saying, again, element-wise, 1, 2, 3, 4, 5. If I were to print it out here, and then the series itself has the little column to the left of it is just an index saying that this is row 0. And we are also able to create a list, which looks like it's the same thing, 1, 2, 3, 4, 5. Now, instead of having kind of like how array starting from the beginning here, let me just make this bigger because it kind of makes it easier to see. We were in parentheses here with this array. And we have the brackets. We have the brackets again with NumPy. We don't have brackets here, but we have brackets again in the list. So it's this repeating kind of notation. It's implemented a little bit differently behind the scenes in terms of memory implications, but it's really not that important for our discussion here. If you're a software engineer, aspiring software engineer, I highly encourage you to really get into the details, meaning the contiguous nature of the memory allocation of arrays. In linked lists, you're able to sporadically kind of parse out the memory so you don't have to reserve the whole blocks at once. And Some other limitations here, just to quickly touch on it, at least in these general programming languages, and it depends, every programming language has its own little spin, but at least with this array, things have to be homogeneous. That is the word of the day. So if I were to type in hello, because this type code is I, which stands for integer, if I were to run this now, it's going to be upset with me, saying string object cannot be interpreted as integer. And again, data types are important because this is kind of related to that topic, but that really deserves its own lecture, its own discussion. And I don't really want to waste too much time here. But again, a lot of this can seem very abstract, and by nature, I think most of data programming stuff is abstract. So it's kind of hard to really wrap your mind around if you're more used to needing a physical component to it. But we can visually see, thankfully, thanks to this IDE here, if we were to something more familiar. So we're able to actually kind of visualize this as a matrix. At least the Panda series looks like that. If we were to do that with a NumPy array, it looks a little bit different. It's the same thing, except now we're doing horizontal with one row instead of looking at it as a column. You can see here it's saying the data type is N64. Oh, I didn't want to do that. And there you have the 1, 2, 3, 4, 5. And with the Panda series, it looks more traditional. So covering this in the IDE, we can now look over to something a lot more familiar, not something so exotic and foreign. It's the array in Excel. So we have two examples here. We have array 1 and array 2. So in array 1 and array 2, we construct the array in two different ways. So one is the kind of traditional way we probably normally work with an Excel array, which is we just kind of fill in the different cells element wise, and we get something continuous. And there's the second way, which is probably the more exotic way you're not accustomed, you might not even know you could do, which is the spilled array. And this is kind of a little bit more traditional in terms of this idea that an array reserves blocks before it can construct anything, fill it in with elements. And if you look at the formula bar here, it is between the little teeth brackets. I don't really know what the actual term for these are, but they're the little brackets with teeth. And so you fill it in with semicolons to indicate you want to go down a column, and you fill it in with commas if you want to go laterally. I guess if you want to go down rows, you use semicolons. If you want to go across columns, you use commas. Now, if you were to look at a formula view, you can see that in our individual cells that are filled with elements, it populates the entire space. With the spilled array, it only populates the first cell and then just kind of reserves the space here. Now, there is a problem if we then try to fill in one of these spaces with another element, because again, these cells are kind of empty, they're just kind of spilling out. There's a problem. You get a spill error. But there's something interesting of note that you can kind of draw parallels to here from Excel's and Python. And that is our ability to operate and iterate through a list elements. So leaving behind the two ways we can construct an array, we can then operate using lambda, which is known as the anonymous function. And this lambda also exists in Python, but is a fairly newer concept in Excel. I believe it came out maybe 2016. And the lambda helper, which is by row, which is what is going to allow us to iterate through the elements of these two arrays. So let us make this invisible. You can see the blue highlight here indicating in our second example array that there is something here. I've just made it invisible. So So let's make it visible once more. So we're going to take that and highlight it here. And we're just returning this because if we kind of make sense of what I'm doing here in the formula, lambda is just saying I. So that is, we're putting in I, and then it just comma, return I. So there's not really anything happening. So we're just saying by row, and in this case we are referencing array 2. But we can just as easily reference array 1. We just have to change the formula just a tad. Just go through each element and return each element. Now, I can do a couple things to indicate what's going on here element-wise. If I add 1 to I, then instead of 1 being turned back, we're going to get 2. And instead of 2, 3, and then 3 and 4, etc. And we can see this is what's happening. We're seeing that behavior happen. Or maybe I'm just want to complicate my life for no reason. And actually, I think I need to use a different helper function. I don't think this will work. I think I need to use scan. Yeah, that's not going to work. Do I want to figure this out now, live on the spot? No, I don't. But I might be able to do this. Might not. Yeah, no. Anyways, not to stress that out. Point here is we can still iterate. We can still kind of parallel the behavior we see in Python in Excel. And that is kind of why it's important to understand these big 3 data structures, because they can help you when you come across a problem. So you want to, operate on these things. These lambda expressions, these things are a lot more safer to use. I guess that's the better word to do, because traditionally, as maybe you guys are aware, maybe this is what you do, you can kind of say, I'm going to multiply this times 2 and drag it down. And that works. This accomplishes what we want. The thing is that it opens you up to a little bit of uncertainty. And where that uncertainty comes from is that since each one of these has its own formula going on, if one of them, for whatever instance, let's say you're updating something and you want to update your formula, and you forget, or you make a mistake, because mistakes happen all the time, where you didn't update one of them. Who knows? Now you have an inconsistent thing. Now Excel will try to warn you, saying that, hey, something's inconsistent. So let me just change this to a 3. And there's the little green square. Now, you've seen it before and you've ignored it, but it's not good practice to do something like this. You don't want that little green square to appear. And you might have a logical reason why that particular element needs to be different, but you really want to ingrain that logic in the functions that you're writing, the formulas that you're writing. So it's much easier to do array-based operations. So we can take this and multiply it by 2, and everything is done, and we have this little blue box to indicate, hey, arrays are happening. So again, if I try to get in the way of the space that it's already being reserved here, it's going to say, hey, you're messing up. But now all I need to do is update this formula. One time, everything is consistent. So array-based operations are the way to go if you're going to be operating with arrays in Excel. And also, one last item of note, unlike the certain implementations in Python where things needed to be homogeneous, meaning the same type, you don't have that kind of restriction in Excel. Excel is very lax with its typing. In fact, often you are not even dealing with types when you're dealing with Excel unless in certain conditions, and there are certain menus, secret menus that you might not have ventured into, that really start enforcing it in the same kind of rigidity you see in Python. But here I can just write hello, and it doesn't throw out any kind of error. And I can even do the same with this one. So I just have to do a little bit more steps. I have to put quotation marks to indicate that it is a string. And there you go. I have hello. So there's no enforcement of homogeneity in Excel. Not everything needs to necessarily be the same, unless you're dealing with certain things, certain secret menus that we will definitely cover here. So I believe that is everything with arrays. Now there are two other main data structures that we will cover: the hash map or dictionary, and also the n-dimensional array. I'm not including it in this particular video because if I did, it would be a 45-minute video and no one wants to really stick around for that. So stay tuned, because the next thing we are covering are dictionaries, or the hash map, or the hash table. All different ways to say the exact same concept. Again, in this world of data, people love calling things the same thing, or even software engineering, people love calling the same thing by different names, but it's all ultimately the same concept. If you want any other thing to be covered, or maybe I went a little too fast and you want to explore a little bit more detail, a certain aspect of this video, please comment down below. And otherwise, go out and stay data driven. And it's been Patrick. Have a good one. Till next time. Bye.